Chapter 7, Similar Polygons. Today we're going to cover Section 7.2, Properties of Proportions. All right, your class opener. A rectangular field has a length of 1 kilometer and a width of 300 meters. Find the ratio of the length to the width. Number 2, for the triangle shown, find the ratio of the largest angle to the smallest angle. And number 3, for the triangle shown, find the ratio of the shortest side to the perimeter. All right, our objective today, after studying this section, you'll be able to solve for an unknown term in a given proportion and express a given proportion in an equivalent form. In a proportion, the first and last terms are called the extremes, while the middle terms are called the means. The easiest way for me to remember this one is if I remember how the parts were written, the top left was the first term, below it was the second term, and then on the right, the top was the third term, and the bottom was the fourth term. Okay. Well, if I think of 1, 2, 3, and 4, and if I write them all just in a list, okay, the extremes would be the parts farthest out towards the ends, and then the means just happen to be the two that are in the middle. The following are all ways to write equivalent proportions. And I know for in proportions that I can cross multiply, which makes things equal, which is how people normally think of this first one. So if I imagine cross multiplying 1 times 6, it's going to equal the same as multiplying diagonally the other way, getting 2 times 3. So here's our standard cross multiply. The next one, the left side, if I still have 1/2 equals 3/6, then I'm also going to get that 1/3 equals 2/6. It's sort of like taking the original proportion and turning it sideways. And the one thing I sort of like to double check is I still notice that if I cross multiply 1 times 6, I'm still getting a 1 times 6. And diagonally 2 times 3, I'm still getting a 2 times 3 when I multiply diagonally the other way. So everything seems to check out. Another one, so if I still have the original 1/2 equals 3/6, then I'm also going to get 2 over 1 equals 6 over 3. All they did was they took the ratios and turned them upside down, and I still sort of double check. 1 times 6 is going to still give me 1 times 6, and 2 times 3 is still going to get 2 times 3 if I were to cross multiply. The next one looks a little different. If I keep my original 1/2 equals 3/6, then if I take the fraction on the left and add the numerator and denominator together and put them over the denominator of 2, it'll equal the fraction on the right if I add the numerator and denominator together, 3 plus 6, and put it over 6. And it might seem really weird that this works, but here's sort of the reason why it works. If I take this fraction on the left and split it up into 2 fractions, so instead of 1 plus 2 all over 2, I'm going to write each fraction separate as 1/2 plus 2/2. And then when I write the fraction on the right, I'm going to split it up into the 2 fractions. So instead of 3 plus 6 over 6, I'm going to write it as 3/6 plus 6/6. Well, if you look, you might notice that 2 over 2 is really the same as 1, and 6 over 6 is really the same as 1. So it's just 1/2 plus 1 equals 3/6 plus 1. And if you subtract off the 1 on each side, you're back to your original proportion of 1/2 equals 3/6. So it's just another thing you can do with a proportion if you need to adjust it or make some modifications. And then the last one. If I have 3 proportions, and I notice they're all the same, 1/2, 3/6, 4/8, I know they're all the same, they all reduce down to 1/2. An interesting thing sort of happens. If you take all the numerators of the individual fractions and add them all up, it's going to be the same as if I take all the denominators of the individual fractions and add them all together as well. All right. So they want us to fill in the blank. So if x over 7 equals 4 over 2, then 2x equals what? I tend to always think of these as cross multiplying. So they're giving me 2x, which is 2 times x. And I know if I cross multiply that that's going to be the same as 7 times 4. So I can write down 7 times 4, or maybe you even had 4 times 7, or maybe you even multiplied them together and you wrote down that it's just 28. Any of those are fine. Number 2, if 2x equals 3y, then 2/3 equals what? And I go back to thinking of the cross multiplying. Well, if I get 2x, that must mean diagonally this way I was multiplying 2 times an x. And if I look at my cross multiplying the other way, to get 3y, it must have meant that it was 3 times a y. So the y goes up there. So my answer was the 2/3 equals a y over x. Number 3, if x over 7 equals 4 over 2, then x plus 7 over 7 equals what? Well, I noticed the only thing that's really different over here is they added the denominator onto the numerator. So all I'm going to do is sort of the same thing. I'm going to add the denominator up into the numerator. So it would be a 4 plus a 2 all over a 2. Or if you wanted to actually add it, you could write that it's a 6 over 2. Okay. Find the value of x. This is just standard cross multiplying now. But I would like you to show the work on how you're getting these. So if I cross multiply, I'm going to get 4 times x is 4x equals cross multiplying the other way. I'm going to get 3 times 8. And I know 3 times 8. So this is really 4x equals 24. Divide each side by 4, and I get a value of 6. Let's cross multiply the next one. And I'm going to start with the variable portion. So I'm going to take 5 times an x plus 2. So I really have to think of distribute. So 5 times x is 5x. 5 times 2 is 10. And this is going to equal what I get when I cross multiply the other way. And if you want to do the multiplying step in your head instead of writing down 3 times 6, that's fine. We know 3 times 6 is going to be 18. Now I just solve the equation. Subtract 10 on each side. And I get 5x equals 8. Divide each side by 5. And don't worry, we can get fractions. 8 divided by 5 doesn't come out nicely. 8 divided by 5 doesn't reduce. So let's just leave it as 8/5. Or you could go to a mixed number, or you could go to a decimal. Our next problem here. So cross multiplying. Here's one thing you can do if you notice this. If you notice that a fraction just on the left or just on the right actually reduces. So I'm sort of looking at this fraction just right here on the right side. I notice that 14 over 10 reduces. So before I cross multiply, if I want to reduce, I can reduce that. So they're both divisible by 2. I could reduce this down to 7/5 if I wanted to. Now the one thing you can't do is you can't reduce diagonally across an equal sign. So you're either reducing with just the fraction on the left or just the fraction on the right. Once I've done that reducing, it's time to cross multiply. It doesn't matter which way I start, so I'm going to multiply diagonally this way. And if I do that, I get 5 times 5, which is 25. 5 times x is 5x. And that's going to equal what I get when I cross multiply the other direction. So I need to distribute in the 7. And I get 7 times x is 7x. 7 times minus 3 is minus 21. I'm going to move all the variables to the right side. So I'm going to subtract 5x. So if I subtract 5x on each side, I'm going to get 25 equals 2x minus 21. If I'm getting the variables to the right, I need the constants to the left. So I would add 21 to get my 2x on the right. And if I add 21 on the left, I get 46. Divide each side by 2, and I get 23 equals x. And your closure. My 3 personal goals for this term are